Hi guys. Everyone can hear me. Before I start, I just want to make sure that my sound is okay and you can see me very clearly. If all is good, you guys just let me know that it's all good. Hi. Oh, hi Sanjay. Hi. Seeing a lot of familiar names as well. Yes. Hi. All good? Can hear me very well. All right. So, hi guys, to all of you who don't know me, I'm Brian. And I will be more than anything today. I am hoping for a very productive 2 hours with you, learning physics together, right? So, as you already know, this is small catering for Form 4 Form 4 physics, Form 4 midterms exams, right? So, over the years, many students have always asked me this question that keeps on coming up. A lot of students always ask the same thing. Teacher, I always look at this exam question and I don't know how to start. I don't know how to answer. Yeah. I don't know which physics concept to apply. And like, how do all those very good students who get A+ know exactly what to answer? Like, how do they know what does the examiner want? What does the teachers want? No? So in my opinion, that is coming back to a little bit lack of something that a lot of students may not have, and that is not being conscious enough of what you have learned, right? As cliche as it sounds, to those who join my normal class, they know this. A lot of the time, I always like to go back to that one physics concept or that one main thing in the class that we have learned for the day, right? Sometimes it's not a lot. Sometimes it's just one thing that you have to know for the entire subtopic, and they will just test you on that one thing. But the question is, do you know what is that? Okay, I give you, for example, a very simple question. Say if in inertia, okay, say if we talk about inertia, Do we know what is that one main concept that we are always tested in inertia? Or I list down a few lah. Okay? I list down a few, and then you try to think about it. You try and see whether or not you know that main concept that is behind each of this physics concept, inertia. What if I ask you what is ticker tape, ticker timer for? What do we use this for? Like, and how do we go about analyzing motion and stuff? Right? Is it all about calculation? Also, other things like what is follow-through action? What is that one main thing that momentum talks about? Right. So a lot of people think, hey, physics like very long, like very hard, because you think chapter 2 is a very long chapter. Yes, indeed, chapter 2 is very, very long. It's in fact the longest chapter you will have in your entire physics. Okay, your entire physics. So by the end of the chapter, by the end of you learning chapter 2, which I think most of you are currently at right now, most of you are at the end of chapter 2, you may have forgotten what is happening in front, right? What is happening in front? So understanding that, oh, actually each subtopic is talking about this main physics concept, and in exam, they are going to test you about that main physics concept. If I were a teacher and I want to set a question on inertia, I'm going to test you on one very important concept in inertia, which is the greater the mass, the greater the inertia. Do you all know that this is the main concept that we are learning in inertia, right? And then also for ticker timer, is it all about calculation? Is it all about finding initial velocity, final velocity, the v, finding the acceleration? Is that all to ticker timer, right? Actually, the main concept of learning a ticker timer, most of you would probably tell me, teacher, I know to analyze motion, okay? To analyze motion, to know how fast or how slow something is moving, okay? Or maybe it's moving at the same speed, right? But when we talk about ticker timer, later we will do some questions and you will see, it's all about looking at the gaps. Do you all know this or not? It's all about looking at the gaps. If the gaps are getting further and further and further apart, it means that it is faster, right? So bigger gap means faster, right? And I want to talk about one more, right? I want to talk about one more, and then we'll start doing some questions. Along the way, I will point out to you which physics concept are we talking about, or what is the important points that you have to take note, all right? So as we do the questions, we will go through them. But I'm just trying to let you be more aware, to think about, oh yeah, actually I've learned about that. I know about this greater mass, greater inertia, but I never knew that it was the main concept. I never knew that that is the main thing that teachers are going to ask me when they talk about inertia, right? So now you know, right? Follow through. What is a follow through action? Say for example, I give you a football. That's a very big football. If you a smaller football, and then this is the padang, and we have this guy is Mr. John. So John is going to try to kick this ball. Okay, John is going to try to kick this ball. But how do I ensure that this ball is going to travel very far and very fast, right? I do this action called follow through. Okay, it doesn't require any more force, any more effort, right? All I have to do is kick the ball and follow together with the ball and kick through the ball, basically. So follow through meaning you don't just kick the ball and just stop there. You kick the ball and you continue moving. And that concept is talking about impulse. The next question, impulse sounds like a very new word. Do you know what is impulse or not? Right. So questions like this, you have to start asking yourself, it will help you to, one thing, understand the whole physics better. Another thing is that it makes it easier for you when you look at your exam paper. You think, oh, I see this John kicking a ball, right? And I want to make this ball go as fast as possible. They are talking about some momentum stuff, change in momentum stuff. I think they're talking about follow through action, and that is the highlight in impulse, right? So yeah, things like this. Okay, so along the way, we are going to go through more and more of these physics concepts, right? And I'll highlight what is important for you. I just hope you try to learn as much as possible in this short 2 hours. Yeah, and I will start with chapter 2 first, okay? Because I think chapter 1 is easier and more manageable. Most people are okay with it. But I'll give you guys the answers later in the form of a PDF, okay? Right. So I'll start with chapter 2, which I think most of you have already finished in school. And then we will enter a bit of chapter 3, okay, which I think most of you have not started or just started the front part only in school, right? So I will just go through some of the important bits that you should take note, right? Oh, I suddenly thought of one more thing. What is Newton's first law of motion, second law of motion, third law of motion talking about, right? So by the end of today's session, we should know everything about all this, right? Without further ado, we get started. So we're in page 5. Let's do this question together, right? It's a short question, but at the same time, let's not underestimate what we can learn out of it, right? Let's look at question number 1. At first, the car is at rest. Okay, at first the car is at rest, and then after that, the car speeds up until it reaches a velocity of this, right? To those of you who right now still don't know what is velocity, think of it as speed. Think of it as speed for now. It will help you to at least be able to do some questions, all right? So, because I know you are at the start of Form 4, maybe some of you still in a honeymoon phase for the first few months, you don't know what is velocity, that's fine. Think of it as speed first. At least it helps you to understand some concepts and questions. The meaning of velocity. Velocity, well, we know, okay, quick question. What is speed? Speed is what over what? Very simple one. You guys try the answer, right? Speed is something over something. What is that? Aha, yes, very good. Right, thank you very much. Yes. Distance divided by time, right? Or somebody said rate of change of distance. Well done, rate of change of distance. But when we talk about velocity, very, very similar, very similar. It is talking about, yes, displacement divided by time. Guys, a lot of the time when you see in physics, you see this word time, it usually will tell you that your definition starts with the word rate. What's so special about this word rate? Why does it relate to time? If we talk about the rate of something going, it is always talking about, rate is always talking about how fast or how slow. Agree or not? Okay, usually if we form a sentence with at the rate of this going and stuff like that, we usually mean that at how fast or how slow this thing is progressing, right? What is the so I just want to say that it's always related to time, how fast or how slow. That is why fast or slow always tell you about time. If you see over time here, 95% of the time, there's the word rate. Okay, rate of how much your displacement change, rate of change of displacement. That's the answer, right? Rate of change of displacement. okay, we don't just say rate of displacement. We want to talk about how much the displacement has changed. Maybe at first it is 0 meter here. Then here he has traveled, I just give you a random value, 100 meter. Okay, so how much has it changed? It has changed by 100. Okay, it has changed by 100. To those of you who don't know what is displacement, displacement is the shortest distance from the starting point to the end point. Okay, I show you a quick diagram to differentiate between distance and displacement. So distance, let's say somebody go jogging, starting point is here, go jogging, go one round, and then this stomach look very weird and then come back to the end point. This is called the distance. The displacement is the shortest distance from the starting to the end point. This one called displacement. You get the difference? So we're looking at the same points. We're looking at the same points, but are we looking at the actual distance or are we looking at just the shortest point, shortest distance from the start to the end? Okay, so rate of change of displacement, really it just comes from the formula. You know the formula, you should be able to write it out in words, right? So don't burden your brain so much. Don't everything also go and memorize. It doesn't work like that. Okay, try to understand. Now let's go and find out the acceleration of the car. So at first, the car is at rest. Quick question. If something is resting, what is the speed or what is the velocity? Yes, it is 0. It is 0. Okay, very good that you all know this. Somebody asked for the definition of velocity. Can we write change of displacement per unit time? Can. Change of displacement per unit time also can, right? But I will just let you know that most of your teachers prefer rate of change. Okay, most of your teachers prefer rate of change, but it is the same meaning. SPM should accept. Okay, SPM should accept. Okay, so yes, very good. If it's resting, it is 0. And this is a keyword, you know, anytime you see resting, 0 the speed, okay? 0 the speed. So at first, this is u equals to 0. This is when the problem comes already. The final velocity is 15. People don't know what is the meaning of u, what is the meaning of v. So just a very quick one. U is the starting or the initial velocity, or the starting speed. V is the final or the speed at the end. Like I said, if you still cannot understand the concept of velocity, think of it as speed first. At least you are able to answer some questions, all right? And then they say, usually we have, you know what? Should I start with S? Hold on. At the start, when you all start to learn physics, it's probably very weird that S stands for displacement, right? Yeah, but it is what it is. S is displacement, which talks about the distance, okay? And then you have A, which is the acceleration. And then T, which is time. Nothing special about time. So, like I said, if it's hard to understand, think of it as speed. Think of it as speed. Acceleration talk about how fast or how slow you're going. Sorry, my bad. I should say whether you got speed up or not. Okay, whether you got speed up or not. So we have, I'm going to write down a few things. The starting velocity, just now you all told me resting means 0. We also have what info? The final velocity. So the car will travel until it reaches 15. Okay. And then 3 seconds. Okay, in 3 seconds. So the time is 3. They say calculate the acceleration. And this. Okay. So I am assuming that some of you don't have no knowledge lah. So if you think that some of you who are very pro already, if you think I'm a bit slower, just bear with me a little bit. I just want to make sure that everyone can follow lah. Okay, I try my best. So there is 5 symbols here, 5. Okay, and to those who have done this a lot, you probably will know that this SUVAT, SUVAT question, every time you do a SUVAT question, SUVAT, meaning you're dealing with the symbols, okay, and dealing with the equations, you can only deal with 4 symbols at a time. 4 symbols at a time. And this is what we mean by 4 symbols. Because SUVAT is 5 symbols, right? But you can only deal with 4 symbols at a time, including the one you want to look for. Okay, why so specific 4 symbol? Can it be 5 symbol or not? Cannot, must be 4. Can it be 3 symbols or not? Cannot, must be 4. 2, cannot, must be 4. Right? You get the idea. It has to be 4. So you need to try to write out 4, okay, including the one you are looking for. And you take a look at your formula sheet, right? Your formula sheet has all of this for you. So I always say you don't need to go and memorize unless your teachers say they don't want to give you the formula list during your midterms, say. Okay, then too bad lah. Okay, if your teacher don't want to give you, I cannot control really. Right? Take a look at each of the formula. There's always only 4 symbols. Is there 5? Never. Is there 6? Never. Is there 3? Never. It's always 4 symbols. Okay, it's always 4 symbols. And there is always one symbol which you are not dealing with. You're dealing with UVAT. You're not dealing with S. How to pick? Look for somebody who doesn't have S. Because in my particular question here, there's no S. You see S, you don't want. You see S, you don't want. You see S, you don't want. Which formula to pick? Is that not obvious enough? Always use this method. 100% works every time. Okay, 100% works every time. 4 symbols, somebody will be missing out of SUVAT. You go and find, I don't want S, don't want all the S. You are referring to this list in exam, you see. Formula is V equals U plus AT. Okay, so your V is 15, your U is 0, your A is a question mark, your T is a 3. I'm going to divide by 15. Acceleration will be 5 meters per second squared. Must have units, must have the correct units. Okay, units must be correct. Okay, Ken? Now we will try and see to do, can we use A equals to V minus U over T? Yes, you can. Yes, you can. This formula is given. Yes, this formula is given. Don't worry. Somebody asked if we can use A equals to V minus U over T. Can. They are actually the same, you know. They just rearrange only some of the symbols. So one is A is the subject, the other one is V is the subject. But they are the same actually. They are the same actually. Let's look at number 2. So we have all of the same information, right? U is 0, V is 15, the time is 3. We even know the A, right? We even know the A, but the displacement is what I'm looking for. And I know that A is equals to, I just calculated, is 5 meters per second squared. Okay, it's 5 meters per second squared. Somebody asks, is formula paper given in SPM, even in the objective part? Yes, it is given in paper 1 and paper 2, both. Okay, and in the last 2 years of SPM, they've made it a little bit easier for you guys. They sorted out the formulas by chapter. They tell you chapter 1, you got all this. Chapter 2, you got all this formula. Chapter 3, you got all this formula, which makes life even easier. So slightly different from last time, the papers, but yeah, but they are making it easier by giving you chapter by chapter. We have a problem right now. Just now I keep on saying, can it be 5? Cannot, must be 4, right? But what happens if you have 5? just cross somebody out. There's too many, too crowded. Cross somebody out. Cross somebody out. Let's say I don't want the A. Okay. You don't want U also can. You don't want V also can. You don't want P also can. But let's say I just don't want to use A, right? Because don't know, maybe I made a mistake here. What if I make careless mistake here, right? So I don't want the mistake to carry forward. I don't want the mistake to bring down to the next part. So I'm going to use something that doesn't have A this time. Okay, something that doesn't have A. So you look for your formula. See, everything that has A, you don't want. Now, which formula are we left with? Only one guy left, and that is S equals to 1 over 2 U plus V T. Okay. We get 22.5 meters. That is the distance or the displacement. Okay. The distance of the, 22.5. Okay. Let's move on. Ken, if you were lost last time with this, I hope now you are better. Ticker timer. Okay, ticker timer and ticker tape. So I will straight away go to the question first. Okay, I'll straight away go to the question first. So we have a trolley, and at the back of the trolley, you have a ticker tape connected to it. So as this trolley go down, it will pass through the ticker timer, and the ticker timer will form some dots on the piece of paper. Okay, so imagine you pull this paper, and then they will produce some dots. Now, a very quick one. Do you guys know how to see what kind of motion is this? Okay, do you guys know how to see whether is it speeding up, whether is it slowing down without doing any calculation? Okay, some people say speeding up, some people say constant acceleration, speeding. Okay, very good. I think you guys have an idea, but yes, Sanjay, very good. We actually just have to look at one very simple thing. You write this down. To see what type of motion, a simple solution I give to you without any calculation, you just have to see the gaps between the dots. Because bigger gap means faster. Bigger gap means faster. If the gaps become bigger and bigger and bigger and bigger, means it's faster, it is speeding up, right? If the gaps is all the same, never speed up, okay? Never speed up. If the gap becomes smaller and smaller and smaller and smaller, that one called slow down, that one called deceleration, right? So in this case, it is speeding up. The gaps are getting bigger gap, meaning it's getting faster and faster. This arrow means that this is the start of it. Okay, that means this part of the tape go in first. Okay, so, but you see that the gaps become bigger, right? It's also very consistent one. No? The most popular question they like to ask you is, what type of motion is this? State the type of motion. Got two answers that they can accept here. Okay, number one, a lot of people said it is uniform or constant acceleration. Number two, oh, no space. Number two, yep. Forward motion, cannot say forward motion. Okay, Pecutan Seraga means uniform acceleration. Oh, somebody said zero velocity. That is a bit scary. Velocity, you think of speed. When you say zero speed, that means trolley never even moves. Okay, be careful of that. Just now we already say that it speeds up. Okay, it speeds up. So it is sorry, maybe I should say velocity is increasing, speeding up. Velocity is increasing, but it is increasing at a very uniform pace, right? It's all 0.8, 0.8, 0.8. So increasing uniformly. They accept these two answers. Okay, they accept these two answers. You write anyone also can. Okay. Now we start to answer the question. Underline the correct answers in the bracket to complete the sentence below. The type of current used by a ticker timer is alternating current. This one must know, alternating current. All right. So what happens if we forget uniformly? A lot of marking schemes are quite strict about the word uniform. If it's uniform, you have to say that it's uniform, or else you will assume that it's a non-uniform acceleration. Okay, so you always notice about the gap also, if you can tell, if you can tell. What's the difference between the two current? Okay, I was thinking, should I explain this? Okay, since you asked me, very quick one. I want you all to think of direct current as a current that continuously flows. Okay, this is just to help you to understand better. A current that continuously flows, for example, from your batteries. Your battery continuously supply current. What happens when you continuously supply current to a ticker timer? Watch this. Your ticker timer is going to dot, 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 dot like this. And if you supply a constant current, it will just dot and it won't come up. It will just dot only and it won't come up. But what if you supply alternating current? Alternating current meaning it will kind of turn on, turn off, turn on, turn off, turn on, turn off. That's why you get your dots, because it alternates. Okay, it's kind of like turning on and turning off. And it will do this for 50 times in 1 second. Okay, 50 times in 1 second. So it will turn on, turn off, turn on, turn off in 50 times in 1 second. Okay, that is why later on when we calculate the time here, we will know what to do, because we know it will do 50 times in 1 second. Somebody asks, is uniform acceleration equal to velocity increase uniformly? Yes. Yes, uniform acceleration is the same thing as velocity increase uniformly. Because accelerate means speed up uniformly. Accelerate uniformly, speed up uniformly, same thing. Okay, let's see. The time taken to travel from point P to point Q, point T. Okay, if you want to find the time, you have to look at the ticks. I got 1 tick, 2 tick, 3 ticks, 4 ticks. Don't count the dots. Don't count the dots, count the gaps. How many gaps? Okay, count the ticks. Each gap here, you must know this value is 0.02 seconds. Right, so we have got 4 ticks. And 4 ticks means the time is 4 times 0.02 seconds. Okay, that's all. I got a quick question to ask you. Do you think a tick, 1 tick, is equals to the distance between 2 consecutive dots? Or do you think it is, so I give you 2 options, okay? I put an underline here. Do you think it's option A, distance? Option B, time? What do you all think? Okay. Good to see some mixed answers. Okay, good to see some mixed answers. Some people say A, some people say B. So that is a misconception, because you see, even when I draw the arrow, I always draw from 1 dot to another dot. A lot of people think it is distance. No, the correct answer is time. Okay, I hope by now you have learned something, right? It is time. When we talk about the tick, it is always the time. That's why the value for one tick is always fixed, it's always 0.02 seconds, because 1 second will have 50 dots, 50 vibrations. And that is how we get 1 second divided by 50 gaps. It will produce 50 gaps. Okay, can? So this value you must remember, but one tick, they will ask you sometimes, what is the meaning of one tick? The time between two consecutive dots. Okay, two dots that are next to one another. Time, not distance. Okay, now we look at average velocity. The average velocity here, to find average velocity, we will take the total time. Total displacement divided by the total time. Okay. Total distance or displacement that it has traveled would be 3.2 plus 4 plus 4.8 plus 5.6. That is how long it has traveled. Let's add all of them up together. And just now we know the total time taken is 0.08 seconds. Okay, so on top, be aware of what unit you are using. We are using cm. You don't want to write here is fine. You don't want to write here is fine, but at the end, you need to know that it will be cm per second. Or if you want to convert to meter also can. Okay, if you want to convert to meter also can. So I'll add the top, which is 17.6 cm, and I divide by 0.08. So you should get this. Some people might want to leave their answer like this. Also can. Okay, also can. Right, next one. The acceleration of the trolley. This is when some people fall into the trap. We know acceleration formula. Let's pull it out first. Okay, let's pull it out first. But to calculate the initial velocity, right? This will give you the initial velocity. So to find out the initial velocity here, I will do the distance right here divided by the time here. Okay, just from the first dot to the second dot. Okay, just for the front part, I want to know what is the speed or the velocity right there. Distance divided by the time for one gap there. Okay, and then I'm going to do for here as well. V is equals to 5.6 cm divided by 0.02 seconds. We get 280 cm per second. I think most of you can get that. Okay, can? So just distance divided by the time. Let me move this down. Let me move this down as well. But acceleration though. Okay. Putting the V is easy. Putting the U is easy. Okay. Putting the V and U is easy. But the time, I want to ask you, is it correct for me to also put this timer? Correct or wrong, this one? Wrong, huh? Ooh, very good. Okay, a lot of people say wrong. Yes, very good. Very good, Cecilia. Okay, we have to minus one tick, or you have to minus one strip. So quick reminder for ticker tape for everyone. Okay, you guys are quite good, not bad. The time here, you must minus 1 tick. Okay, you must minus 1 tick, or let's say if you are talking about strip by strip, then you have to minus 1 whole strip. Only for acceleration. Okay, only for acceleration. Okay, let me tell you why. The 160 and 280 that you calculated for the U and V, okay, we found out that here's 160 meter per second. Here is 280 meter per second. We are actually not looking at the value, to be fair, right? We are not saying that the velocity here is 160. I'm not saying the velocity here is 160. I am saying that the velocity in the middle is 160. Because I need to be fair. I can't say that it's the front. I can't say that it's the back. I have to say that it's in the middle, right? That's the simple explanation. Then here also. That's why for your acceleration, you have to measure the time from here to here, which means in front, you minus half a tick. Behind, you minus half a tick. That's why half and half, you would always need to minus 1 in total. Okay, you always need to minus 1 tick in total. Important, this one, small trap. So you cannot use 0.08. You have to use, instead of 4 ticks, you have to use minus 1, 3 ticks only. Okay. So on top, you have 120. At the bottom, you have 0.06. And you get 2000. On top is cm per second. Here is second. So you get cm per second squared. Some people may write it as 20 meter per second squared. Also can. Okay, your friend answer you, yeah? Can I? All right. Only to find acceleration, you need to minus 1. That is right. Only for acceleration. Okay. Sometimes they give you the ticker tape in a form of just 1 strip. Sometimes if the strip is too long, okay, if the strip is too long, then what I do is I'll go and cut the strip. Okay, I'll go and cut the strip, but I need to cut in a way that makes sense also. I cannot just simply cut. Okay, I cannot simply cut, right? So if I want to cut the strips, I need to make sure that each of the strip has the same number of ticks. Okay, same number of ticks. Let's say all of the strip here, they have 5 ticks or 10 ticks, right? It has to be the same number of ticks. Because imagine this lah. Maybe got one strip only got 2, got another strip got very long, then got another strip only got 1. Like, how are you going to analyze? What is the point of analyzing this graph? Just doesn't make sense, right? So if you simply cut the strip, doesn't make sense. Therefore, for your ticker timer chart, your ticker tape chart, it will always be the same number of ticks. Okay, you cut, and then you paste. Okay, you cut and you paste. So describe the motion of the object. So we have a few parts here. From X to Y is a different type of motion. From Y to Z is a different type of motion. Let's bring back the main thing that we talk about on how to decide. I don't need to give you any value, and you don't need to do any calculation. To know what kind of motion, you just have to see the gaps. Look at the gaps. Are the tapes getting longer or not? The tapes are not getting any longer. Same speed, same velocity. Okay, so you say constant, or maybe I write here, from X to Y, we have, you can either write constant velocity, meaning same speed, never get faster, never get slower, traveling at the same speed. Okay, or you can also say zero acceleration. Also, they accept. Meaning never speed up. 0 speeding up. Acceleration means got speed up or not. Okay. Then from Y to Z. This one you all want to try or not? Okay, this one you all want to try or not? Constant deceleration. Very good. Well done. Constant deceleration can? Constant or uniform is the same meaning, lah. Which means slow down constantly. Okay. You can also say, velocity decrease. Correct. You can also say, velocity decrease. Is it uniform or not? Like that, not enough. Yes, it is uniform. How to tell? You see the gap becomes shorter and shorter and shorter and shorter. Slow down. Okay, so bigger gap, speed up. Smaller gap, slow down. Okay, velocity decrease very, very uniformly. It keeps on minus 2 cm, minus 2 cm, minus 2 cm. Okay, can? Right. So you just write one answer will do. They accept both. Okay, let's look at the next question. You take a look at this graph and you guys see if you can answer part A or not. Okay, you see if you can answer part A or not. They give you a velocity time graph. From what I know, a lot of people don't like this velocity time graph topic lah. All right, so you have two cars. This is a velocity time graph. And they ask you to name the quantity that can be determined by the gradient of the graph. The gradient gives you what? Okay, I can tell they suddenly become more quiet already. Okay, yes, very good. Thank you very much. All right, to make it very simple for you guys, I need you to remember this order S, V, A. Okay, displacement, velocity, acceleration. Because all you have to know, right, is that if I want to convert S graph to V graph, V graph to A graph, what I am trying to do if I go forward, find gradient. What I want to do if I want to go backward, find area under the graph. And that is everything, okay lah, not everything, but that is the backbone of the entire chapter 2.2. You know this, you can answer a lot of questions already. So if I got a V graph, so I always ask my students, you go and write out SVA, and you go and circle what graph is given to you. Okay, what graph is given to you? You circle this one. So this is the graph they give you. If question asks you to find A, find gradient. Because you go forward, if you go in front, you find gradient. If you go behind, you find the area. So if the question later asks you to find out displacement, you know already, you can find the area underneath the graph. Okay, so the gradient is the acceleration. Can? So this one SVA will tell you exactly what you need to know. So you see, you circle what graph you have first. Then if they ask you about acceleration or ask you about gradient, you know they're talking about the same thing. Okay, if you go backwards, they ask you about S or ask you about area, you know they're asking about the same thing. Right? Yes, yes. Okay, very good. Thank you very much. So now we go and answer part B. Okay, we go and answer part B. Describe the motion of both cars. Okay, maybe I go and answer here first. For car A, this is for part B. Yeah? For car A, the motion is, you see, the velocity is here, and then the velocity constantly go up like that. Okay, the value of the velocity keep on becoming bigger. How should we answer the motion? Or, okay, uniform velocity cannot accept. Uniform acceleration can accept. So you say accelerate uniformly, or uniform accelerate. How you phrase your English, that one not important. That one not important. Okay, constant also can, or uniform acceleration, but it's not uniform velocity. Uniform velocity means what? Uniform speed. Velocity is similar meaning to speed. But the speed keep on changing, or at first is 5, let's say, and then become 10. You see, no? The V keep on changing. So it cannot be constant velocity. It is uniform acceleration, or the simpler version, you go and say velocity increases. Right? You see the V keep on increasing, but it increases at a very consistent rate. So some people will start to ask me, teacher, I know this one come from where, because I see the graph keep on going up, and this is velocity graph. So the velocity keep on going up. But how do you know it's uniform? How do you know uniform acceleration? This is when you pull out your SVA again. Okay, you pull out your SVA, you circle the graph that you have. Let's say you want to talk about acceleration and you are unsure about it. You want to talk about acceleration and you are unsure about it. If I'm going forward, you have to take a look at the gradient. So I want to talk about acceleration. Now let's talk about, or let's look at the gradient. The gradient of this straight line, any straight line will have the same gradient, guys. Same gradient meaning, let's say I simply put a value, the gradient is 5. Okay, the gradient here is 5, here also 5, here also 5. Got change or not the gradient? Never changed. Gradient is 5, acceleration also 5. Okay, yes, very good. Straight line, right? Straight line. Same gradient, same acceleration. So you have to know your SVA really. Going forward, find gradient. Going backwards, find area. Next one, car B. Car B a bit more complicated. You have the front part same, front part same. Maybe I say first 3 seconds, okay, or 0 to 3 seconds. Yeah, accelerate uniformly. Or you can say velocity increase uniformly. So same as the previous answer. Okay, but after 3 seconds, okay, after 3 seconds, should I say, okay, I ask you all, you'll see if it's okay for me to write like that for this part. Should I say that it become at rest already? Because the graph is flat, should I say that? Okay, thank you very much. Okay, that means you're still with me. Yes, not resting yet. Hello, the value is 24. How can it be resting? Very good. Constant velocity, right? Constant velocity. Or you can say, you see the value is just at 24. Or 0 acceleration. Bagus. How come? Because gradient is 0 here. Okay, gradient is 0 here. So 0 acceleration or no acceleration can, no problem. Okay, so that is the answer for part B. Let's look at part C. Let's look at part C. Okay, I move on. Calculate the acceleration of car A in the first 3 seconds. I got velocity graph. I faster pull out this one first. I got velocity graph. They asked me to find what? Ask you to go forward. Imagine you are a person walking. They ask you to walk from V, walk until A. You are walking forward to the right. Okay, meaning go and find your gradient. Go and find your gradient. Okay, so the gradient for the first 3 seconds for car A. Do we have enough value or not? Do we have enough value or not? The value is not 8 though. It looks like we don't have. It looks like we don't have, but guys, the whole thing here, isn't it the same gradient? Yeah, so do I have to look at just the first 3 seconds? Don't need. You go and look for 2 points that has some values. Yeah, so 2.4 is correct. The answer 2.4 is correct. Yeah, you don't have to use the first 3. You can use up to here. Because the straight line have same gradient. Yes, 2.4 is correct. So this here is 0, 0. This here is 10, 24. Right? So acceleration in 0 to 3 seconds is equal to acceleration in 0 to 10 seconds. Because same gradient. Can understand? So the acceleration is just finding the gradient. This one is maths already, not physics already. You take the y coordinate 24 minus the y coordinate of 0. You take 10, the x coordinate minus the x coordinate of 0. You get 2.4 meter per second squared. Can or not? Okay, meter per second squared. Okay, very good. Somebody asks, is the recording playback of the class available? I am not too sure. Can you ask the admin? Divide by 10 and then times 3. No. You're understanding wrong already. Somebody say, do I need to divide by 10 and times 3? No, the gradient here is 2.4. The gradient of this line is 2.4. This one also 2.4. Here also 2.4. Anywhere here is all 2.4. The gradient is always the same, meaning the acceleration at any point is always the same. Don't go and divide. Don't go and divide. Same only. Hello, you all learn already, ma? Y equals mx plus c. This gradient is 2.4. It doesn't change. Whether you are here, whether you are here or here or here, gradient same. Okay, same. Okay, can I will move on. So that is a bit messier. Hold on, let me move this down. Let's continue to let's continue with the next part. Now, give me a moment. Okay. So they say, diagram 4 shows the motion of 2 identical toy cars. Okay. A and B before and after the collision. So yeah, before the collision, after the collision. Before the collision, they say it's stationary. After the collision, they move with some velocity. So B is stationary only, sorry. Then A is not stationary. Okay, quick question. If you see they look like this, can you all tell me what kind of collision is it? Are you able to tell what kind of collision this is? You know how to see or not? Yes, very good. Those who answer inelastic, very good. Inelastic collision. How to see? Because they stick together. Right? Stick together. So inelastic, they combine together afterwards. So what about elastic? When you think about elastic, I don't know about you, but I always tell my students when I think about elastic, first thing that comes to my mind is rubber band, right? Rubber band. So you stretch a rubber band and it bounces off, right? It bounces off, right? So elastic means it will bounce away. It will separate after the collision. Okay, it will separate after the collision. Then the third one we have is explosion. Okay, third one we have is explosion. So I'm going to talk about this question in elastic collision. They gave us some momentum before and after the collision. What is the meaning of momentum? We answer the question in part A first. Momentum is mass times velocity. The word times, in maths, you write times like that lah. Yeah. In English, you write the word product. Okay. Yes. Thank you very much. Product of mass and velocity. Okay. Based on the diagram, determine the total momentum before collision. Guys, they gave some momentum before for car A and car B. Momentum after for car A and car B. But now they want the total momentum. Total momentum. You cannot just write the equation. Cannot. You have to write the words. The meaning, or to define, you have to write the words. Okay. Last time maybe can, now cannot already. Very strict. Total momentum. So you have to add up total for A and B before is 4. The total for A and B after is 4. Before 4, after also 4. Okay, so you just have to say 4, but you need to put the value kg meter per second. 4 kg meter per second. Okay, they already gave you the values here. So before is 4, after is also 4 if you add together. Okay, so this is pointing towards a certain direction, right? Hold on. So I finished the question first and I tell you what is this about. Part C, they ask you to compare the answers in B1 and B2. Compare. Or you just say the total momentum are the same. The total momentum before and after the collision is the same. Okay, you can say equal also can. Right? We compare. Compare, usually you say, are they the same, or is it bigger, or is it smaller, that kind of thing. Okay, state a conclusion about the momentum. Actually, this one also the same. The conclusion that I can make is total momentum before and after the collision. So happen this one is the same answer. That's my only conclusion I can get. Okay, the principle, yes, the principle will be in the next part here. Okay, so at this point, right, I think some students will have in mind that, oh, this is talking about principle of conservation of momentum. If you have that in mind, very good, very good. But if you are someone who after doing all of this already, you're still a bit lost, like, hey, where is this about? Okay, you don't have to worry, right? You still have time, okay? You still have time. But it's just a reminder to you that actually, good students, you should be able to look at the kind of question or even the diagram only and immediately know that where is this coming from, so that you don't give wrong answers, you don't give the wrong principle, you don't explain with the wrong concept. Cannot, right? All these things you learn under that one most important thing in momentum. The most important thing you learn in momentum is the principle of conservation of momentum. Okay, what is conservation? Okay, do you all know what is the meaning of the word conservation? What is a simpler word for conserve? Some people say to save. Yeah, some people say, I need you all to think of it like this. You just think of it as maintain. You know, a lot of people say, hey, this principle, a lot of things going on, very hard lah. Too many things going on already, right? But to me, even when I teach, I always tell my students, guys, everything you need to know is already in the name. Everything you need to know is already in the name. You see, principle of conservation of momentum. Conserve meaning to maintain or to stay the same. Why I say everything you need to know is already there? Because they are trying to tell you momentum will stay the same. That is all this principle is talking about. Momentum will stay the same. Can you see it? Conserve means stay the same. Conserve, that means total before and total after is the same, right? That's why the total momentum before and the total momentum after is the same. Just now you all told me momentum. Momentum, usually we use the symbol P is equals to the mass times the velocity. Okay, so you have the mass of this guy, the velocity, the initial velocity of this guy. You have the mass of this P, and you have the initial velocity of this guy. That is what we mean by the total momentum. What about the total momentum here? You have the mass of this guy times the final velocity, mass of this guy times the final velocity. You see not, I'm just doing this formula 4 times because I got 4 objects. I got 2 before and 2 after. What does the principle say? The principle says total momentum will conserve, will stay the same. That is how I get my formula. Can or not? So if you understand what the word conserve means, the name would tell you the formula. The name will tell you the formula. And the name will also tell you the definition. Because the definition is just total momentum before collision and after is the same. Okay, provided you don't go and apply any external force onto it. I will talk about it later a bit. Yes, P is also pressure. Okay, P is also pressure. Okay, so that is the highlight of momentum already. Okay, that is the highlight of momentum already. Yes, Asru. Elastic collision is also that, but it's the same lah. It's the same. So this one is the general one. Okay, the general one. If the velocity is the same, you can use that same. Okay. So that is our answer for this. If you write any other answer, confirm wrong. I've seen people write inertia. I've seen people write just the word momentum. I've seen people write impulsive force. Immediately, I know, okay, this person didn't learn it very well. Didn't learn it very properly, right? Because momentum, same already so obvious from the start. Conserve the momentum. Okay, state one condition in order for the physics principle to be obeyed. You say there is no external force. Yeah, you can say it's in a closed system as well. Or you can say there's no external force acting in the system. I'll explain this statement in a bit. No external force meaning there is no, in a perfect situation, momentum will be conserved if there's no other forces. External force could mean friction, air resistance, all that stuff. Okay, so we are saying that the momentum is only conserved if you, if we assume that it's a perfect situation, got no other external force. Okay, no other external force acting on it. Physics concept and principle and law. Okay, somebody asked the difference between the principle, the law, physics concept. So physics concept can be anything, can be law, can be principle, can be any topic, the name of the topic even, can. Principle usually will have the word principle. Law usually have the word law lah. Okay, yeah, law usually have the word law. All right, and then part E, this one I already tell you the answer. Give reason. You can say something like this. The toy cars combine and move together after the collision. Okay, the toy cars combine and move together after the collision. So keyword is they will stick together, they will combine together. Okay, together, they combine. Or some people want to write more canggih, you want to say, the more fancy way of saying it would be, they are going to have a constant velocity or a common velocity after the collision. Also can, right? If you understand that, can, or else you stick to the simple way. You just say that they will stick together. Stick together also can. Okay, I see the word together, or I know that you understand they will combine together, then can already. Okay, can. We move on to the next one. Toy car move with the same velocity after the collision. Can. Okay, same velocity, or better still, you write they move with a common velocity. Can, no problem. Okay, now I'm going to move on to the next question. This next question very popular. Let's see. It's a very good question. We got two different eggs. Oh, okay, I asked you all something. You all know what topic is this? Or what physics concept is this is talking about? Just by the picture. Okay, okay. Okay. So at the start, some people say free fall or impulse. Huh? Some people say free fall or impulse. Now, it is talking about impulsive force only. It looks like it is falling, so some people say free fall. But no, the whole topic in this question is talking about this one main concept. And in impulsive force, the highlight of it, the most important thing you have to know is this. Okay, I will write it down for you straight away, which is if you have greater time of impact, then you would have smaller impulsive force. Okay, this is the highlight of the whole impulsive force. When I say highlight, I don't mean it's everything in the topic. Please now, you don't quote me. right? Don't say I studied like that, I know this one sentence good enough. No lah, you also have to understand what we are talking about mainly in impulsive force. So for impulsive force, we are usually talking about the type of material. Okay, the type of material. So you see, I drop them from the same height. By right, they have the same momentum. Okay, by right, they have the same momentum and same velocity by the time they reach down here. But how come one will break, one will not break? I speculate that this is a soft surface and this is a hard surface. And impulsive force is mainly talking about soft and hard surfaces usually. Okay, how come soft surface will not break? Because the egg can sink into the surface, take its time and sink into the surface. There is more time of impact. When it impacts the soft surface, it will sink into it. Okay, it will sink into it. So more time of impact. And therefore, there'll be less force on the egg, less force on the egg. And the reason is very simple. It's because of this formula. Take a look at F and T. When your formula 1 is on top, the F is on top, the T is at the bottom. The relationship that we can get from here would be greater time, smaller force. They are inversely proportional to one another. Inversely proportional. Okay, inversely proportional. Yes, very good. So yeah, impact time can understand now. So the egg fall, that is the impact. Impact time is how long does it sink onto the surface. Okay, does it just hit and immediately stop, or does it sink slowly into the impact? That is impact time. Okay, that is time of impact. Just like when you do high jump. Okay, usually high jump got this stick one, right? And then somebody will run lah. Run, and then jump. If I don't go and put a mattress here, what will happen? Okay, if I don't put a mattress here, what will happen? The person is just going to run and jump and hit the concrete floor, you see? Very pain, right? But do you know how to explain that or not? Do you know how to explain why very pain or not? We say the impact force very high, impulsive force very high. How come very high? Because you put concrete floor, very hard. What will happen? It will just hit the floor like that. The time of impact very short. But if I go and put a mattress, okay, I go and put a cartier there. This person run, he will hit on the mattress and he will sink into the mattress. You see, the time of impact is longer. Sink into the mattress. Time of impact is longer. More time of impact, shorter impulsive force. Okay, so the key here is talking about the time and less force lah. Okay, less force, shorter time of impact. Okay, can understand? Okay, now let's try to answer the questions here. So I tell you the highlight already of impulsive force. Okay, the meaning of impulse. Okay, impulse is different. So impulse, they are asking for, the formula for impulse is like this. This one is mass times velocity, is momentum. Okay, but it's final momentum. Then this one is also momentum, but this one is initial momentum. When you take final minus initial like this, can we all agree that it is just looking for how much the momentum has changed? That is the meaning of impulse. Okay, change in momentum. Hey, sorry. Sorry, yes, I made a mistake here. My bad. Correct. Thanks for letting me know. Okay, for a hard surface, the time is shorter. Okay, shorter time. Sorry, I made a mistake. Shorter time. more impulsive force. Please correct this if you have written this down. I've made a mistake. Terrible one, sorry. Okay, more force. Got a lot of force so that the egg can break lah. Huh? Compare the force on the eggs that hits the surface. Okay, we already say lah, right? But you all need to know how to answer comparing questions. Huh? Usually, most of the comparing question is like this one. Who is bigger than who? Who is higher than who? So it's either bigger, somebody is bigger, somebody is smaller, or are they the same? Okay, but you write down what you want to compare first. You write the force on the X that hits. Okay, so this is what they want us to compare. They want you to compare the force on the X that hits which surface. Okay, so I write the force on the X that hits surface A is smaller than on surface B. Okay, because I know surface A got less force. That's why it doesn't break. Surface B got more force. That's why it breaks. Yeah. If you want to write greater than, less than, if your teacher say can, go ahead. In SPM, can in structure questions only. Essay questions cannot. But I don't recommend it now. Okay, you write it in words would be better. Next one, the time of impact. We also answered already just now, right? So you write down what you want to compare. Copy only. The black color words I copy only. Huh? You don't have to say surface A first, or you can say surface B also can. Like I say, don't worry about the English part of it lah. Huh? It's a physics, yeah, physics. So it's not an English paper, so don't worry. But I'm interested to know what you all will write for part C though. The change in momentum, that's what they want to know. Okay, the change in momentum of the X. Okay, so yes, Cecilia, you're right. Okay, so we have a few answers, but most of you gave me, most of you say the change in momentum in A is smaller than B, or B is bigger, right? You think this one has more change in momentum. Their change in momentum is actually the same. Okay, the change in momentum of the X in both situations is the same or is equal. Let me explain. Okay, why are they the same? Okay, why are they the same? So they are the same because of this. Imagine this, guys. At first, the egg, you want to drop it. The speed is usually 0. Okay, by the time it reach here, it will speed up. But you drop from the same height, right? So let's say it will speed up until it becomes 2 or let's say 3 meters per second. Okay, when it reach here. So same for this situation. At first, the egg is 0 meter per second. You let it drop from the same height, and then it will speed up, speed up, speed up. It will accelerate, and then it will become this speed, let's say. The change in the speed is the same. The change in the speed is the same. And also, it means that, let's say the egg is 0.1 kg. Okay, I simply put this value lah, just to make it easy. So if you go and take the momentum of this, where you times mass and velocity, and you take the momentum here, times mass and velocity, do you think the momentum got changed or not? Mass times velocity, mass times velocity. Yeah, the momentum really never changed. Okay, at first the momentum is 0, and then because they will speed up the same way until you reach the same velocity, the final momentum is the same. So how much the momentum change for both situations is the same. Okay, how much the momentum change for both situations is the same. But what affects the force? What affects the force is the time, the type of surface, the type of surface. So for impulsive force, our focus is usually talking about the time, a little bit less on here. Okay, provided that this is constant lah. In this situation, mv minus mu is the change in momentum. So change in momentum is the same because you drop it from the same height. What affects the force is the type of surface, whether you allow the egg to sink in, you give it more time or not. Good up? Can up? Yes, I think you all gave answer for part C already. Very good. Okay, which is what I wrote up here already. The greater the time of impact, or the longer, the bigger also can. Impulse is not directly proportional to impulsive force. We do not mix impulse and impulsive force in a lot of things because when you say impulse is directly or non-directly proportional to impulsive force, actually, if you want to establish that kind of relationship, you always have to make sure that other things are constant. Okay, so let's say if I want to compare only F and T, I have to make sure that the top part is actually fixed, right? So you can say that F is directly proportional to mv minus mu, the impulse, provided if the T stays the same. Okay, provided if the T stays the same. Okay, so it is directly proportional, but unless if the time is the same. But I don't want to confuse you guys. Main concept is still here. Okay. Yeah, your exam asked this and then you wrote. Yeah, I think a lot of people would write that the momentum is bigger and stuff. Okay, the greater the time of impact, the smaller the impulsive force. Okay, you let it absorb the shock. You let it fall into the soft cushion, let's say. Okay, and you let it absorb the shock. So for part D, right, suitable material for surface A, a soft material, you can say a sponge is the best answer. Okay, or anything soft. Anything soft also they accept. A thick cloth, okay, maybe a latex, rubber, and stuff. Okay, I really hope I have enough time. What is the difference between impulse and impulsive force? Polystyrene is quite hard, no? Polystyrene is quite hard, no? Bubble wrap maybe can. Bubble wrap maybe can. Yeah. What is the difference between impulse and impulsive force? Impulse is like this. Impulsive force is like this. The highlight for impulsive force is the greater the impact time, smaller the impulsive force. The highlight for impulse is, okay, impulse got another formula, by the way, which is J equals to Ft. But this T, I want you to think a bit differently. Okay, I want you all to think a bit differently. The greater the time of action of force, okay, which means how long you apply the force, okay, the greater the time of action of force, the greater the impulse, and also the greater the velocity. Okay, I'll explain very quickly one. So impulse, this is the highlight. Usually we talk about follow through action can help us to increase the impulse. For impulsive force, usually we talk about the type of material that can help us to change the time. Is it soft or is it hard material? Okay, so I talk about impulsive force already. I know you guys know about impulsive force stuff, but impulse, a very quick one. Remember at the start of the session today, we talk about if you kick the ball. Okay, if you kick the ball, everything you do is the same. It's just that you go and follow through with the ball. That means you kick the ball and you let your feet touch the ball and follow through with the ball. Okay, imagine now. So your feet touch the ball and you follow through. What happens here when you follow through, right, is that you increase how long you apply the force. You apply the force for a longer time on the ball. Okay, you apply the force for a longer time for the ball. So it's actually coming from here. If the time you apply the force onto the ball is longer, your impulse will also increase. Okay, you apply force, the time that you apply the force is longer, right? Try not to mix impulse and impulsive force, the concept. The calculation you can mix, but the concept, try to separate it. It will help you to answer questions a bit easier. Okay, so you apply force for a longer time because you follow through and the impulse will increase. And when you increase the impulse, it means that you get more change in momentum. More change, more momentum. Let's say you got more momentum, meaning what? You are traveling faster. The football will go and travel faster. Same goes to golfer. You use a golf stick and hit the golf ball. You don't just touch the golf ball. You would hit the golf ball and follow through. You would continue that motion so that the golf stick will touch the ball for a longer time. You apply the force for a longer time, more impulse. The golf ball can now travel further. In short, it is more time, more impulse, more velocity. Okay, in short, this one is more time, less force. That is the highlight of the whole topic. A very, very important topic. Be aware for your midterms. They will test this. They'll also most probably test you on your principle of conservation of momentum. Those are the favorite, exam favorite. Okay, exam favorite. Shall we move on? Impulse is not momentum. Impulse is the change in the momentum. How much the momentum has changed. Okay, how much the momentum has changed. Okay, can I move on? Okay, can. Part E. I will do this together. I will do this together. Let's see. Okay, we have a pile and a pile hammer. Okay, a pile and a pile hammer. Usually we use a pile to create a very strong structure before we want to build buildings. Okay, like let's say you want to build your twin tower. Okay, you want to build your twin tower here. We need to have very, very strong structure underneath the ground. All right, so the pile is for that purpose lah. The pile is for that purpose. But a lot of students don't understand how to explain this pile concept. And it's really just, imagine this. It's the same thing as a nail and hammer concept. If you can understand how a nail and hammer works, you will be able to understand how a pile hammer and a pile works. You hit the nail a few times, the nail will go in, right? And both of them are made of very hard surfaces. Therefore, very short time. You don't allow the impact to sink in. Very short time, a lot of force. That is what we are going to talk about. Okay, so let's brainstorm together a bit. It is very hard, right? They are both made of metal usually. They have a very short impact time. They have a very high impulsive force. See, I'm brainstorming for my answer because they asked me to explain. And also, a bit of side note, usually we drop it from a certain height. Okay, usually we drop it from a certain height. Let's say here, and you let your power hammer fall. Okay, you let it fall. If you give it more space to fall, it will get faster and faster and faster because maybe we say this object is very heavy and it has an acceleration of 9.81 meter per second squared, right? So you give it some time to fall, it will fall down, and then it will hit at a very, very high speed and high velocity. Okay, so you drop it from a higher height so that the speed here is very high. Okay, imagine you drop your power from here to here. Okay, the reason why the momentum is very small is because you don't give it more time. You need to give it more time to become faster and faster and faster. So it has to be faster, 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 and then it hits the power. Hits the power, and then it will hammer down the power into the ground, right? So it's that concept. So we say we want to drop it from a certain height or a high position so that I have more speed. When I have more speed, I have more momentum. Speed is always related to momentum. Okay, or to be more specific, the change in momentum is more. Right, so they ask you to explain how a large force is produced by the power hammer in driving the power into the ground. Right, let's explain a little bit. Okay, let's explain a little bit. So I think I will just write, should I write here? Yeah, maybe I will just write here. So I'll say something like this. We start with the hard surface. I'll say that the hard surface of the power and power driver will decrease the impact time. If it's a soft surface, then you can sink into the shock. More time. Okay, now this one less time. Next one. We will also say that the impulsive force is inversely proportional to the impact time. If you don't like this sentence, if you don't want to use inversely proportional, you can just say the smaller the impact time, the greater the impulsive force also can, which is trying to explain, right? How come decreasing impact time will give you more force? It's because they go opposite way. Less time, more force. Less time, more force. Huh? So that's what I'm trying to explain. I'm trying to explain my first point there. And then my next point, as the pile driver or pile hammer is dropped from a high position, it will also create more momentum. If you are faster, you have more momentum, right? Drop from a high position, the velocity and change in momentum are greater. Yeah, so because on top here you have more momentum. Sorry, this one I know. Usually I say impulsive force, the mv minus mu is constant. Like just now you drop the egg, change in momentum is the same. But now I increase, there's a slight crossover here between impulse and impulsive force. The change in momentum, I want it to be higher so that I get more force. But at the same time, the time here, I want it to be smaller so that I also have more force. Right? So it's the combo of these two. Okay, it's the combo of these two. A large force is produced to hit the pile deep into the ground. Of course, you have to hammer a few times. You have to hit a few times for it to go into the ground. Yes, pile hammer is pile driver. Correct. You can use hammer or driver, same. Okay. Yeah, the pile hammer is also usually quite heavy. You can talk about that as well. Can. Okay, I am going to talk about the essay question down here. But the other essay questions, right, I'm just going to give you the answers later on, right? Because I want to go through a bit of chapter 3. Okay, I want to go through a bit of chapter 3. So, Dana. So for the next part, they say, the question is here, down here. Okay, you have 4 tankers, K, L, M, N, with different specifications. You are required to determine the most suitable tanker to deliver highly flammable fuel safely. So this tanker that we talk about is those, those Petronas or Shell tank that you see on the roads, right? You have some wheels, and then usually there's some spacing here. And then usually there's a driver inside. We're talking about this tanker, okay? So we have 2 parts. We have, this is the head and this is the tank. Okay, this is the head and this is the tank, right? So that's the front part and the back part. sometimes they can even detach the head and the tank. They ask us to design the most suitable tanker. Okay, the most suitable tanker. First of all, we look at how many tanks we want. Do we just want one huge tank, or do we want smaller tanks? Okay, one huge tank or smaller tanks? I hope you have in mind that we want a smaller tank, and it's because of a yeah, thank you very much. But do you all know how to explain? Yeah, inertia. Okay, inertia. Because when you split up the tanks into smaller tanks, what happens is that you will immediately cut down on the mass. Remember or not? What is the highlight of inertia? Smaller mass, smaller inertia. Actually, you all know what's the meaning of inertia, not? Do you want me to explain what is inertia? There is the tendency of an object, blah, 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 right? But inertia, right? Okay, I know that there is the main definition, but if you want to use inertia to explain anything, just remember this. Inertia is how difficult to move or to stop something. If you say yes, or I said in my class, it's just very stubborn. Sometimes I say it's very stubborn. You're right. Or so if I say if it's high inertia, meaning what? Meaning this guy has, or this guy is very difficult to stop or to move. Okay. Give you super easy example. Elephant versus bicycle. Elephant has big mass. Okay, big mass, the bigger the mass, the bigger the inertia. But what does that mean? What does that mean? Bigger inertia means more difficult for me to go and to move or stop. Okay, bicycle has smaller mass, smaller inertia. I think we all agree it's very difficult to go and push an elephant for it to move. Or if the elephant is running at you, it's very difficult to stop the elephant. Why? Elephant very high mass. Elephant very high inertia. Okay. Meanwhile, bicycle, very small mass, very small inertia, easy to move or stop. Okay. I have explained the whole subtopic of inertia in 3-4 minutes. That is all you have to know, really, for inertia. Okay, inertia is easier because there's no calculation. So you understand this concept, you can answer it. All right, so back to our question. We want smaller tanks because you split up the mass of the petrol inside, let's say. Okay, and then the inertia will be less. That means when you want to, let's say when you stop the truck, okay, when you stop the tanker, the petrol inside, right, will not be so difficult to stop, meaning it will not be thrown back and forth like that. Because if the whole petrol is thrown back and forth in one single tank, something disastrous may happen. When the whole petrol flow back and forth, there is a lot of inertia and a lot of force of the liquid. The liquid maybe is 1 ton, 1,000 kg, maybe 2,000 kg, right? And this very heavy liquid can hit the front part and it may even hit the driver. Okay, this whole thing may be detached and it may hit the driver. Or it may, in worst case scenario, it may even roll down on the road, on a highway, for example, right? So these days it's quite safe already. These days it's quite safe, but it's never good to deal with too much at a time. So we deal with small parts. So if the driver stop the whole tank, the petrol will just shake a bit only, right? It will not be too much shaking. It will not be too much shaking. So first one, we say, I want more number of small tanks. Okay, the reason is to reduce the negative effects of inertia. Okay, reduce the negative effects of inertia. Because we don't like, we say negative effect, meaning this inertia doesn't help us in any way, right? This inertia doesn't help us in any way. It only creates negative effects. So we say, I want to cut down on, because I cannot avoid it. So too bad, I cannot avoid it. So I cut down on the negative effects of the inertia. Okay, next one, number of tires. More tires better, right? More number of tires. You can say that so that it's more stable, or it can withstand more load. Okay, withstand more load. Third one, you say you want to use a anti-lock braking system. Okay, this one is not in your syllabus. Okay, this one is not in your syllabus, but it's in the old syllabus actually last time. But I think you should know about it because some teachers, they still recycle the older questions. Okay, the older questions. More tires. Why not use air brake? And yes, anti-lock braking system is to avoid skidding during a sudden brake. I'll explain what this system does. Imagine this. Suddenly you see a cow. Okay, you drive on the highway. Suddenly you see a cow suddenly walk onto the highway, and you suddenly want to stop. So what happens? You would press your brake very hard. We call this a jam brake. You jam your brakes very hard. You press your brakes very hard. And what happened? Your tires are moving very fast, right? Suddenly the tires stop. When the tires stop, it will lose grip of the road. At first, it is gripping onto the road very nicely and it's moving very fast. Suddenly, you stop it totally. What will happen? It will lose grip of the road and it will start to slide as if it is sliding on ice. It will slide on the road. It will slide on the road and it will start to turn like that. Okay, we call it skidding, that one, right? Just like your Fast and Furious movies, right? Turn, and spin like that. Okay, so we don't want that to happen. That's why we need an anti-lock braking system so that it doesn't lock up our tire. It still allows the tire to slow down, but it still grips onto the road. It doesn't lock it up entirely. It's better to hit on something than to turn on a highway like that and you hit many cars, right? So it's to avoid skidding. Yes, you will lose control of your car, right? You will lose control of your car. Now, the last one, we want a long distance of tanker head and tank. Okay, we are talking about the distance here. Okay, we're talking about the distance here, right? It's so that if you increase that gap, right? If one day suddenly this guy hits onto something, right? Hits onto something, you are going to create more time more time before it hits the very, very heavy 2000 kg petrol tank behind. Okay, can you imagine if in front you have a huge wall, behind 2000 kg also trying to hit you from the back? The 2000 kg will also crush the driver, and this driver will become a hamburger. We don't want that. Okay, so you give it more space, to increase. So we use the air space there as like a extra time or extra cushion, that kind of thing, to increase the time of impact during a collision. Okay, or else you'll really become a hamburger, right? In front also, you hit on something, behind at the same time, there's a lot of inertia for the 2000 kg petrol, and it will crush you and hit the tanker head as well. The whole thing will crush at it, right? So we don't want that, right? So at last, we will say, I hope you all know that usually we write the answer in table form. Okay, you draw a table in exam. Okay, one side you write your modification or your specifications, right? Your modifications or your specification. One side you write your reasons. And then at last, you write your conclusion. Okay, your conclusion is you tell them who did you choose and why. Okay, I chose tanker M because it has all of this. These are your specifications. Okay, because it has more number of small tanks. You just copy only, comma, more number of tires. It uses anti-lock brake system, ABS. Okay, it has a long distance. You get the idea. You can see I literally copied only. Okay, Ken? Do we write 4 specification for this kind of questions? There are only 4, right? You see this 4. So you just write this 4. You give your reason. 1 specification and 1 reason will give you 1 mark, 1 mark, right? So 1 specification, 1 mark, 1 reason, 1 mark. And then your conclusion there, you choose who. The moment I see you choose M, okay, I give you 1 more mark. And Y, you just copy it, I give you 1 more mark. So here in front got 8 marks lah. Here behind the conclusion is 2 marks. Okay, you put it in a table form. Okay, welcome. Ken, and also one more thing I want to remind you all. Do you notice I didn't write 5 tanks? I didn't write 5 small tanks. I didn't write 8 tires. Right? I didn't write that. Try, if you can, don't write the numbers. Okay, if you can, don't write 5 tank, 8 tire. Don't write the numbers. Why? Because in your specification, you tell to them, okay, you tell them what are the best designs, right? What are some of the best designs, right? What are some of the best designs? So I want to design a tanker which has a lot of small tire, a lot of tire, use ABS and long distance between tanker head. And then our conclusion will tell us which one has it all. Which one has number 1, number 2, number 3, number 4. So you tell them what you want. That is what I want. And then I say, okay, tanker M has it all, right? Tanker M has it all. And you tell them why, because tanker M has everything that I said that I want, right? So it's you are designing from the start to the end. Designing from the start to the end. You tell them first, okay, I want this, I want this, I want this, I want this. That's why we don't write the numbers. And then at last you choose. Okay, you say M is chosen because M has all the things that you say you want. That is how you do an essay question. So usually this comes out in section B. All right, I will. Okay, unfortunately, it's already 4 o'clock. Okay, it's already 4 o'clock. I would do one concept on chapter 3, one concept on chapter 3. Spare some time explaining the application of a jet engine based on the principle of conservation of momentum, like the working principle. Can. Let's do that. Okay, let's try to do that. I know it's very packed, this 2 hours. I'm really trying to do a lot of things, and I know what it can do to your brain. Okay, so let's look at this rocket. Let's look at this rocket. I will explain the working principle in page number 13. Okay, in page number 13. So we have a few things. Okay, just give me a quick few minutes. We have a few things here. Number one, usually for our rocket, even up to the modern days right now, we will use a special fuel called, we don't use petrol. We use liquefied hydrogen and oxygen. That means oxygen and hydrogen. We don't use petrol for one very simple reason, because we want to create a lot of exhaust gas. You want to burn hydrogen and oxygen, and you want to produce a lot of exhaust gas. Okay, why? Because when you produce a lot of exhaust gas, so if you burn petrol, you don't get that much exhaust gas. We need a lot of exhaust gas so that you have some backward momentum here, and this rocket will gain some forward momentum. The value of these two momentum is actually the same. They are equal. And it's for this reason. Okay, so this is actually an example of an explosion. Because at the start, the rocket is just at rest. Okay, for it to be explosion, it must be resting first. And then after that, your rocket will start to fly. Okay, your rocket will start to fly upwards. Meanwhile, your exhaust gas will fly downwards. So at first, based on the principle of conservation of momentum, okay, total momentum before is equals to total momentum after. If before that, my total momentum is 0, okay, before equals after. After that, my total momentum will be the mass of my rocket times the mass of the exhaust gas first, maybe, times the final velocity of the exhaust gas. The mass of the rocket times the final velocity of the rocket. So I get M1 V1 plus M2 V2. But before that is totally not moving one. Then how come suddenly we'll have some momentum? Like, where did that momentum come from? It's because like this. You go and move one of these guys over, you will get like that. Which is telling you their momentums are actually the same, but they are negative of each other. They are in the opposite direction. Meaning to say, you have a momentum, let's say, of 100, I just simply put a value for you, 100 kg meter per second going up. You have another momentum, 100 kg meter per second going down. Going up and going down, if you go up and go down like that, the momentum, total momentum will be 0 because they cancel out each other. So actually, we are supposed to say this is maybe positive 100, this is negative 100. And the total momentum after will be equals to 0, positive and negative. right? So the principle of conservation of momentum to explain rocket is using this concept. We say that the forward momentum and backward momentum is the same magnitude, but in the opposite direction. That is the working principle of a rocket. Okay, Ken, that is the working principle of a rocket. Okay, Ken. Well, I guess we have no time for chapter 3. Okay, maybe one, yeah. Yes. Give me a minute, a quick minute. Universal law of gravitation, page 15. I just want to talk about one formula real quick. I think most of you have learned this already. Right? If you want to state Newton's law of universal gravitation, you just take a look at your formula in the formula sheet. And then you can say, oh, F is directly proportional to M1, M2. F is inversely proportional to 1 over R squared. And then you just write it out in words. That would be the answer. Okay, you can say gravitational force is directly proportional to the product of masses of the bodies and inversely proportional to the square of the distance between the centers, right? But I think no point I go through this because a lot of you still haven't learned yet, but I'll give you all the solution. You can try to do later on. With that, I will end my session here today. Okay, the rest of the answers I will give you guys later on in this PDF file. Okay, I hope you all learned a thing or two today. Yeah. Thank you very much. Thank you very much. Okay. You're welcome. You're welcome. As long as you have learned something. Okay. Good luck to you guys. Bye-bye.